that we use a percentage and then we use a D. Let's save this right now. Let's erase this. Okay, let's save this. Now let's run this. Now you see this is number 4. So what is actually happening behind the scenes? I have already shown you how to plug in two separate arguments together inside using this printf function. Now the plugging actually occurs when you provide this format specifier. This is known as a format specifier. Why is this a format specifier? Because behind the scenes, when we try to what we are telling the compiler is that we are giving the compiler two numbers and we are giving it an arithmetic symbol. So the plus, minus, divisions and subtraction are known as an arithmetic symbol, or these are the arithmetic operations. So we are telling the compiler that you need to take these two numbers, 2 and 2, and you need to add them together. So when the compiler encounters this line 4, it's going to take up both of those numbers and it's going to compute them, and it's going to find out the result for 2 plus 2, which is 4. Then when it sees that it has got a format specifier with the format specifier starts with the percentage symbol and it ends with this D. Now there are several types of format specifier. We're not going to look into all the details of the format specifier until chapter 2, which we're going to look into next when we discuss about variables. Now when it finishes computing and it finds out the result, it takes the result and it places that result inside this format specifier. It's actually like, let me actually increase the font size so you can get a clearer view. Okay, I guess this is better. Okay, now it's taking it's like taking this entire expression. It's taking this entire expression, it's computing this. 2 plus 2 is equals to 4. This is the result. So it takes the result. Then when it finds a format specifier of something like this is a format specifier, and it will always start with this percentage symbol. It will take that result and it will plug it into that format specifier. So ultimately your compiler will replace that format specifier with the result of 4, and it will get you will actually get an entire string of characters. These are also characters, and an entire string that constitutes of characters and numbers. So you might see two different stuff in here. One is the string. A string is essentially a collection of characters. Now characters are like by character, what I mean is that this THIS has got 1, 2, 3, 4. So it has got 4 characters. So each of this individual letter can be regarded to be a character. And inside a compiler, your compiler will always read them as individual characters placed together inside these double quotation marks. Now when we try to compute, when we try to calculate something like this, you can even do something like this, which is also 4, which means 2 into 2. In our human terms, this is something like this. 2 into 2 makes it 4. So if you do something like a computation inside your printf function, so this expression will evaluate to something different. It will evaluate to a single value like this. So because we are using a because we are using numeric values, 2 is a numeric value, then again we are also telling the compiler that you need to use an arithmetic symbol. In this case, this is the plus or the addition symbol. Then again we are also telling the compiler you need to add this first number, with the second number. So because both of them are numeric values or both of them are numbers, we need to write them without the string, without this double quotation marks that we used for the string literal. So this part is known as the string literal, this part is known as the numeric values, obviously, or this is also known as the arithmetic operation. So because inside this string, inside this double quotation marks, whatever you provide, if you write anything inside this double quotation marks, it's going to print out exactly those characters in the same manner as you did. So in the same context, it's going to literally print out whatever you give it to, whatever you provide to the compiler. So that's why it's called a string literal. It will do literally everything that you ask it to do. So this part is, this format specifier is actually working like a plug. It's plugging this computational value that you get after you do the arithmetic operation. You are plugging that result with this format specifier. There are several others. There are several other format specifier which we'll be looking later, which we'll be looking at a later time when we discuss about variable, and I'll ask you to watch chapter 2, because we're going to discuss about the arithmetic operations, we're going to discuss about the variables, and we're also going to look at the at other format specifiers. So this is actually a better way to write something inside your string rather than doing all the computation just by yourself. You might even go for writing an entire equation inside your printf function. It might be a complex one. Suppose you might ask your program to do something like first you multiply 2 into 3, then you divide that number with something like 6. So this is a simple equation, and you can provide that inside your printf function, and you can use this plug or this format specifier to view the result. Your compiler or your program will ultimately do all the computation or all the calculation by itself, and it will ultimately show you the result on the console. You don't need to do the calculation just by yourself. So you are saving a lot of time just by doing the computation inside your printf function. So the printf function, as we can see, is capable enough to print out a string. It's also capable enough to print out a number. At the same time, it's even capable enough to do a calculation just by itself. So it's a powerful function that we can use, and we will be using it all throughout this course. So behind the scenes, actually, when you ask your compiler, when you ask your IDE to build this, so I have already shown you what these two separate buttons do. One is used for building, the other one is used for running. So the building purpose is to the build, when you ask it to build the program, it's going to compile it. Now the compilation occurs something like this. Let me show that using a simple diagram. So this is your, let me consider this square to be your program. So we named it as something like print name. name.c. So this is your program. This is using a library function. So you are bringing in the functionality from another file called standard input or stio.h. So this standard input and output file or this header file contains all the definitions or all the it contains the body that defines the actions for this printf function. So it brings in the functionality for that printf function inside your program that we know as print name.c, and we can see that in here. So when you ask your compiler to build this, it goes through when you ask your IDE this code blocks to build this, it goes through a compiler like this. A compiler is something like a processing unit. So this is the compiler behind the scenes. So it compiles your code into something that the machine can understand. But before it can compile your code completely, it needs to look at the library functions or the library functionalities that we are using. So it adds, during the compilation part, it adds all those functionality. Like if you use a printf function from a standard input, it's going to use this printf function inside your